All right,
Right?
Grace,
Yes.
what would you like me to do?
I don't know. Can you do number 2?
Just read me the problem.
Cosine
Yeah, I have that.
equals negative 0.707
Theta
theta.
equals negative 0.707, okay?
And then it's 2 pi is less than or equal to
Theta,
theta. Yeah, and then 3 pi.
okay. Calculator, unit circle. Calculator, how do you know? It's a decimal. Okay. So we'll start by figuring out the quadrant. I notice that cosine is negative. Where's cosine negative at? S and T.
Is there another way to find like what area it's in besides drawing the graph?
I think it's the best way of doing it by far.
Is there any way you could show us the other way?
I don't know what the other way would be.
Wait, why did you highlight S and T again, sorry?
Where cosine is negative, right? Cosine is equal to a negative value. So that's S and T. The letters tell you what function is positive in that quadrant. A for all of them, S for sine, T for tangent, C for cosine. If the function is not negative there, or not positive there, then it's negative. Yes, Julius?
Are you gonna give us like the chart that shows which ones like are positive and which ones negative on there, like?
The ASTC?
Yeah.
No.
Remember also.
All silly turtles crawl.
Oh, yeah, but like, for, there's specific ones where cosine is negative,
So which one's
That's where it's not positive.
And if it's A, then
Yeah.
it's all of them.
but then there's other ones like tangent and sine.
The ASTC tells you where both things are positive, and then if it's not positive there, it's negative. So like S means sine is positive.
negative?
So what's negative there? Cosine and tangent. So it has that in there, right? You see what I'm saying? Okay. Next, I want to find out what quadrants are covered by 2 pi to 3 pi. I start counting at 0. Which direction am I going to go? Clockwise or counterclockwise? Counterclockwise. Why? 2 pi and 3 pi are positive angles. Each quadrant is a half, so I'm a half, 1, 1 and a half, 2, that's the start, 2 and a half, 3, that's the end. So we started at 2 pi and we ended at 3 pi, so we covered those 2 quadrants. Where will my answer lie? Quadrant 2, where the 2 overlap. Will they always overlap? Unless your teacher made a mistake on the problem, they should always have just one place of overlap. So I draw my answer. So that's what my theta is going to look like. Gianna?
On the quiz, does it have a thing where it's like if it's minus alpha or plus alpha?
I can write that for you guys. Now, since it's in quadrant 2, I can use this formula to find my theta. What is the x1? 3 pi. How did you get it?
How many times you missed?
I read it off the label that's in the same spot, right? That's why I made sure to write down the labels as I was counting around.
Wait, how'd you get that?
So I'm left with 3 pi minus alpha. How do I compute alpha?
Inverse cosine of 0.707.
Inverse cosine of the absolute value.
Wait, so if it's the absolute value, wouldn't that be positive?
Yep. I'm just gonna write down
Okay.
so you guys can see that I'm doing something. Because if it's a positive, I just write it down, you get in the habit, it's just the inverse
Yeah.
of the thing. I'm gonna write the absolute value every time I write it, so you guys are in the habit of like doing that. And then this is just into your calculator it goes. And then whatever the answer comes out is you're done. Charlie.
Could you do number 11?
I will do 2 total problems.
Do one with the,
I will do 11 if that's what everybody else wants.
is that one with the calculator?
I have no idea.
Oh wait, yeah.
Yeah.
I'm not, I don't have the sheet in front of me. I'm just gonna rely on,
Wait, is the answer like -35?
you should be in radian mode, not degree mode.
How do I change?
Press the mode button that's right next to the second button. Where it says
Do you only,
mode.
what do
And you
we
wanna
have
make sure you're
round
in it.
for the?
2 decimal places sounds great.
Analog.
Oh, I see it.
Lily, where do you go?
Mode. It's that button right there, and then change it to radian.
Yeah, and then alpha is the.
What is?
My calculator.
So you do the cosine, you do the
Okay.
cosine of it, and then you do the absolute value.
So then that's the answer?
Whatever that comes out to on your calculator, yep.
I got syntax error.
That means that you typed in a symbol inappropriately. So I can't tell you what the problem is with the syntax and without looking at your calculator, what you typed into it, but it means you used the operation improperly. So maybe you did like 2 negative signs in a row, or sorry, 2 subtraction symbols in a row, or you used subtraction where you meant a negative, or
Was it 8.63?
something like that.
Yeah.
So that means that if it's right here, sine tangent cosine of it's right here, sine.
Okay,
Divided by calc?
divided by nothing. I said that just means that's what you typed in your calculator.
So I want a negative cosine. Since I know cosine.
That's a good one.
Positive sign, then it's gonna be the other two. Makes sense.
All right.
Yeah.
Is 11 an acceptable second problem?
It's just the, if it's.
Yeah.
I don't know. Charlie, what worksheet is
Like
this?
this, you can't,
Yeah, but it's not
If the cosine's
Negative
negative,
2
it's
and
not
square root.
cosine, cosine should be positive. And in all, cosine is also positive, so it should be.
And then the range.
oh, right here, it's, secant equals -2 square root 3 over 3.
Okay.
And then it's 3 pi less than or equal to theta less than or equal to 4.
Okay, so
Example number 2.
it's all. This one's sine.
First thing I'm gonna look at, is this a unit circle or calculator? Good, because you see the square root 3's and the fraction in there is usually a dead giveaway. So before I start trying to figure out the quadrant, I want to rewrite this as a sine, cosine, or tangent problem. Secant is the reciprocal of cosine. So I'll do that, write secant as 1 over cosine. And then I'm going to flip both sides of my equation to turn it into a cosine problem.
Wait, how'd you do that?
I flipped both sides.
Oh, okay. Wait.
And I probably want to rationalize that denominator, because that still doesn't look like a unit circle value yet, but it's kind of looks like one. I'm hoping that when I rationalize the denominator, that'll take care of itself.
So
So that means that the first three in, so whatever, 1, 2, 3. And that means it's
So the square root of 3 times the square root of 3 is just 3.
And then.
Yep.
Yeah.
Square root of 3 times square root of 3 is the square root of 9,
But like, say if I did.
which is 3.
Like what he did, his was like, sine.
Now that certainly looks like a unit circle value now, correct?
Yeah.
Now I'm happy. Let's start
Yeah.
the problem just like we did the previous. So I'm going to figure out where my answer is.
This is just a straight
I notice that cosine is negative.
A, S, T, C, S. So take alpha. So it's like here.
What quadrants are covered by cosine being negative?
S&T.
S and T.
And here's this. And then that's down. That's alpha.
And then we have to figure out what's covered by 3 pi to 4 pi. We did that exact same thing above though, didn't we?
Second, and then 2.
Do it again. 0, half, 1, 1.5, 2, 2.5, 3, that's the start. 3.5,
And then absolute value, you just make it.
4.
Does that say 5 pi over 2 on top?
Yes.
That's alpha. So then you just find whatever both options.
So are we all so far so good?
Yeah, so that's this one.
and you put
So
the
that's
blue
alpha.
because that's where it is on the circle.
3 pi to 4 pi. So 0, half, 1, 1.5, 2, 2.5, 3, that's the start. Shading after 3.5 to 4. So shade at the bottom.
How do you get those numbers?
Every quadrant is a half a pi.
That's just to find out.
Use a decimal if it's more comfortable for you.
Like half? Like
Yeah,
just
Just do 0.5 pi, 1 pi,
Okay.
1.5. Just convert it all into decimals if that's easier.
Yeah.
Okay.
If the number's too small, it's added by 2 pi, right? Not multiplied.
So
Yes.
it's-
So now we look in
That's sine.
on the unit circle. We're going to look in quadrant 3 for what?
Negative 3
or
X.
X. Why X?
Because it's cosine.
Because it's cosine. So I'm going to go to my unit circle in quadrant 3 and look for where the x coordinate is negative root 3 over 2. What angle is that, Grace?
7 pi over 6.
Okay. Before I finish though with this, I need to check, does that lie in between 4 pi and 3 pi? 7 over 6 is 1 and 1/6. Is that between 3 and 4?
No.
Oh, what do I do?
Add 2 pi.
Add 2 pi. How do I know add rather than subtract?
Because it's smaller.
It's too small. So I just add 2 pi to that. To add 2 pi, what am I going to need? Common denominator. The common denominator would be 6. So I'm going to write it as 12 pi over 6. That gives me 19 pi over 6. That's 3 and 1/6. That's between 3 and 4. I should be set. What do you think, Grace? Better than when you walked in?
Yeah.
Sometimes that's all we can ask for, right?
If it's a 1 on top, just the bottom matters. Okay, so just put them on and just tangent. So tangent equals sine by cosine. So we look at sine and cosine. So sine divided by just it has to do with it. So if I divide that, it's gonna get it's gonna be the square root of 3. Yeah, and you get this really great. But I don't want that, I want.
All right, you drop your phone in the holder and grab a note card, and I'll give you a quiz when you come back. You do need a calculator. You don't have one. You need one for this. I promise you cannot be done without a calculator. Unfortunately.
My phone died, can I borrow one to try?
Actually, one year's in the charger.
Oh, is there one?
On the power strip there, there's a couple of chargers.
And then these ones that are
Might as well
straight,
plug yours in so you have a charge on return it.
What do you think? I get one more light on it, too.
So there's 2 on the front and 2 on the back. I think they've all been spoken for. Would you like to go on a calculator hunt?
Yeah, can I just run to Mr. Boyle?
Yeah, that should be fine.
Run to Mr. Boyle.
I am short 2 calculators. I have been short 2 calculators for a while now. If you in your travels find either of my missing red calculators that say Kulik on them in yellow tape and return them to me, I'd be much appreciated.
What's the reward?
What do you want?
Extra credit.
Sure, 100% on a quiz, extra credit, that would be fine.
100%, can I just buy you a new one?
I mean, it's like $100-something investment.
So an A
For
and
the
a
If you're not getting an A in that, like,
Not as much.
that's too big of a reward.
But it's $100.
I'm not asking for $100, I'm just asking for my calculator back. They exist in this world, they're there. I don't think you need to spend $100 with me.
No.
It's bad, you never know when things go south, that unit.
No.
Yeah, I think you're alright. Oh, you're. Gotcha.
Mr. Boyle's not there, so I got this Morgan.
Okay. I need to start taking collateral for my calculators. Maybe
Take their shoes.
Stop.
Nobody else forget their shoes. No, people would forget their shoes. There's a pair of socks in Mr. Smith's class.
Dude,
Crystal would forget her shoe.
Crystal, I don't even, there's some things you don't really need to hear in this room.
About leftover socks in Mr. Smith's room. Could be worse, could be underpants.
I don't know how you would lose those.
You never know, maybe you got them scared off of you or something. The psych quiz was that bad.
It was.
It really was.
It wasn't that bad.
And apparently everyone could go. I don't know how.
I didn't check my grade animals.
When will you close your tablet? Just, I'm sure you're not using it, but it looks rather suspicious, not that I thought you were doing anything nefarious. We got one more topic in chapter 4, and it's a relatively easy topic. We're going to be talking about angles of elevation and angles of depression. I'm not going to define those 2 terms with words. Rather, I am going to draw a picture and kind of label. Okay? So let's say we have 2 people in our picture. One person standing higher than the other. If they both are looking just straight ahead, this would be like their line of sight, right? Everybody's okay with that? if the person up high tilts their head down to look at the person below them, this angle here is called an angle of depression because they've taken their line of sight and they tilted their head down. Everybody feel okay there? And actually, I'm going to write it like that, just for extra clarity. Let's say now you're the person that's on the ground. If they want to look up at the person up high, they're going to tilt their head up. We call that the angle of elevation. So if you're line of sight, you have to tilt your head up. That's an angle of elevation. Is everybody happy with kind of the picture we've drawn here? Feel adequately well defined about what we mean by when we say angle of elevation or angle of depression? Okay. All the problems that you're going to be responsible for doing in section 4.2 are of the story problem variety. Considering they're all going to involve like angles of elevation or angles of depression, what's going to be a key skill is going to be drawing a picture. So that is going to be like, sure, it's going to be like your key first step in any of these problems is to be able to draw a decent picture to represent the situation. So let's run through some examples. Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the building? The first step is going to be draw a picture.
This one.
So here's me drawing a picture. Here's Christy. Here's the base of the building. There's the top of the spire. Everybody feel good about what I drew? And we're told we have an angle of elevation. So Christy is going to crane her neck up to look at the top of the spire. Where does that 66 go?
Corner by K.
In the corner by the K. What other information am I given in this problem?
She stands 200 feet away from the base.
Okay, where does that 200 go?
Bottom.
KB, right? Okay. And what are we looking to find?
How tall is
How tall, which is
TV.
SB?
SB, right? That's supposed to be an S up there. I'm going to just call that X then for my unknown. Does everybody feel okay so far? What final piece of information can I assume based on the way buildings are built? Julius?
There's a 90-degree.
It's a 90-degree angle, yeah. You can assume that, like, people stand perpendicular to the ground, buildings are built perpendicular to the ground, trees grow perpendicular to the ground. For the most part, like, that's the way things want to do it, you know? Everybody's okay? So, this now just becomes a right triangle trig problem, right? So, relative to the 66, what sides are we interested in? Opposite, adjacent, or hypotenuse?
Opposite.
Opposite
Adjacent.
and adjacent. Which trig function should I be using? Tangent. So I can say tan of what angle?
66.
66 is equal to,
200 over X.
ooh,
Wow.
tangent
Over
is
200.
opposite over adjacent, so it should be x over 200. Everybody feel good so far? To get the x by itself, what do I need to do? Multiply both sides by 200. Now, before I type this into my calculator, let me ask you a question. What mode should my calculator be in? Degrees. Well, how do I know it should be in degree mode? The angle is measured in degrees, right? It's told me in the problem. So before I go and do anything on my calculator, I'm going to change my mode to degree mode because I know I just did stuff in radians. Mr. Kulik, am I going to have to switch my mode back and forth on the test? Yeah, you're gonna. So you have to be careful about whether the problem is in radians or degrees. So when you do 200 times tan 66 in your calculator, what do we get here?
439, please.
439.21 feet. Sounds, what'd you say?
449.
449.21 still?
Yeah.
Okay. That sounds good. Hardest part about this was drawing the picture, right? Once you have the picture drawn, it's like, oh, this is just like a right triangle trig problem. NBD. The next problem says Jane has climbed a tree and is looking down on her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? Okay, well, let's start drawing our picture. So there's Jane, climbed a tree. Looking down at her friend Mary. So here's Mary. And it says she's looking down. So that's my sight line down. Jane has climbed 17 feet into the air. Where does, let's give this a B for base of the tree. Where does the 17 go? JB. And it says the angle of depression is 49. Where does the 49 go?
J.
Where at on J?
On the tree, the top of it.
So you're wanting to put J here? Or I'm sorry, the 49 there?
Yeah.
That is the incorrect place. This is the most common mistake students will make on this. Technically, no. J's line of sight is here, so her angle of depression is that spot. Right? If you are in the tree and you're looking straight ahead, your line of sight is here. You tilt your head down to look at M. That's your angle of depression. Now, what can you say about Jane's line of sight and the ground?
41 degrees.
What can we say about Jane's line of sight and the ground?
It's going down.
What did you say? Parallel. Those lines are parallel. Absolutely. And what is her new line of sight here? Relative to those two parallel lines, what's that called? Starts with a T.
Oh, tilted.
It's a transversal. We're going back to geometry. You have two parallel lines cut by a transversal. 4 things should come to mind.
Triangle.
Right triangle. No, 4 right triangles.
Alternate interior angles,
Oh, opposite.
same side interior angles,
Opposite interior.
opposite exterior angles, and corresponding
I got
angles.
all of that.
Now, what other angle is going to be parallel to the 49 that we've labeled? Or I'm sorry, like a congruent. Well, we should be specific.
M and B, or,
You should say BMJ.
oh,
This angle would also be 49 degrees because of what we know about parallel lines. Is everybody okay? So, Addie, at one point you said the 49 went by the M, but that wasn't the angle of depression we were talking about, although it is still 49 degrees. I just wanted to be clear as to that's not really what the problem is saying, although that was the right spot to put it.
okay.
Or a correct spot to put it, not the right spot, but a correct spot. Is everybody okay with the picture we've drawn?
Yeah.
You feel good about how I labeled things and why the 49s go where they go? Okay? I know that was some geometry recall that you're like, "Ugh, I tried to expunge most of that terrible experience from my memory. But it's nice to have still in there rattling around. All right, our last sentence says, how far is Mary standing from the base of the tree? So what side are we looking for?
MB.
MB. So I'm going to call that X. So, relative to this 49 degrees, what 2 sides are we interested in? Not opposite and hypotenuse. Yeah, opposite and adjacent. Which trig function should we be using? Tangent. So we can say tan 49 is equal to opposite over adjacent. To solve for x, what should I do?
Multiply 17.
No,
1 over 17.
I wouldn't do that either.
Divide by 17.
I would multiply by x. Why would I do that? Because I don't want the fraction. If you multiply by 1 over 17 on the right-hand side, every single one of you would have written x and not 1 over x. Get rid of the fraction first. Multiply by x. So you have x times tan 49 is equal to 17. Isn't that much better with no fraction, Lily?
Can I go to the bathroom? Sure.
Now that you've done that, what do we need to do to get x by itself?
Divide 2.
Divide by tan 49. Yes. And then we'll type that into our calculator, and what do we get?
14.78.
14.78 sounds about right. Is everybody okay here? I'm gonna promise you on your test, you're gonna get a story problem similar to this, where it's, if you draw the picture wrong, you're gonna put the angle of depression in the wrong spot and get the wrong answer. Promise you'll see that again. So I don't know if that's note card worthy for you or not, but I'm telling you right now, this setup where you're gonna wanna try to put that angle of depression in the wrong spot, I promise you'll see that same setup in the test. Okay? That's awfully kind of you, Mr. Kulik, to tell me that. You're welcome. All right, last example, and we'll be done for today. That's awfully nice, too. Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When, I guess it should be they, when they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? What's that? Claude and Simone are just weird?
Yeah.
I mean, they, you know, like, they're into angles and math and stuff. I know, right? Weird. All right. So our first one.
Wait, Mr. Kulik, how do you know if you have to draw that like line thing that you did on the last one?
The line of sight.
Yeah.
Typically, I'm going to worry about that if the person is in the elevated position,
Okay.
right? So if in this problem the person was on the top of the Eiffel Tower, I would probably worry about that. If they're on ground level looking up, I'm not going to worry about it because it's the angle depression ones where it's easy to put the angle in the wrong spot.
Thank you.
Uh-huh. All right, so we did the first one. We look up, and it's supposed to be 32 degrees.
What is C1?
Well, because we do it again. Right, Claude and Simone, that's their first time. And then they ride 100 meters closer, or feet or something, 100 meters. I'll call this spot C2. And they look up again. And the angle of elevation is changed. We want to know how tall the Eiffel Tower is.
So would you only use the inside one?
Well, if I look at this, do I know two sides of any right triangle that I've drawn in this picture?
Isn't it, you have two, because it's C1 minus 100, right?
C1 minus 100. What do you
No,
mean?
Is that one side?
So you're talking about this piece here, right?
Yeah.
Okay, so that's unknown to us also, correct?
Okay.
We don't know that. So we can't make any argument about this right triangle because we're missing two sides. And we can't make anything argument about this triangle because we're missing two sides. And we have the big triangle. Use the green. And then we have the little triangle. Neither one of those two right triangles do we know two sides for, correct?
Yeah.
Bummer. So what am I going to do? Well, this piece is part of both of those two triangles, correct? I'm going to give this piece a variable name. I'm going to call it y. And what I'm going to do is I'm going to set up a system of two equations because I have two unknowns. I have this x and I have this y. So if I look at just the green triangle, I can say that tan 37.5 is equal to x over y. Everybody okay with what I did?
Why would you do tan?
Because the two sides that I care about are opposite and adjacent.
What's the other side again? We don't know. Opposite adjacent.
So I'm taking this green triangle, just read,
Hypotenuse,
rewrite.
why not that one?
Because the hypotenuse isn't part of both triangles,
Oh, okay.
right? I cared about this y because this y is part of both the yellow triangle and the green triangle. I can't set up a system of two equations unless they share the variable in common, right? Does that feel okay? Okay. And then using the yellow triangle, I have this, but what is this bottom side gonna be? How am I gonna, what do I have to call this? Because it's,
Two.
because it's this. Well, I need it to be, I can't have a third variable in it. What am I gonna call that bottom side? Excellent. Gabby's got it. 100 plus what? Does everybody see the 100 plus y, where that came from? So again, the two sides I care about are opposite and adjacent. So I can write another tangent equation. Tan 32 is equal to opposite over adjacent. I have two equations with two unknowns. What am I going to do to solve this? That creates a system of two equations. Think back to Algebra 2 from last year. What are the two primary algebraic methods you can use to solve a system of two equations? One technique starts with S and the other starts with E.
Substitution.
Substitution,
And elimination.
elimination. That would be our probably best method, would be choosing one of those two. So there's my system. As it's currently written, I don't think this system is a particularly good candidate to use either method. Do you?
No.
No. What is the first thing that Mr. Gulick would do?
Multiply by x on both sides.
I wouldn't do x.
Why?
I would get rid of the fraction. So for the first equation, we can multiply both sides by y. In the second equation, I would multiply both sides by 100 plus y. Notice no more fractions now, right? Something else is really nice has happened. What else do you see that's nice that happened?
X is that side.
Yeah, what does that scream to you to do?
Substitution.
Substitution, absolutely, very good. So we can take the left-hand side of this equation and set it equal to the left-hand side of that equation since they're both equal to x, right?
What's the other one again? Elimination?
Elimination. That would be a poor candidate to use for this one.
Mr. Cole, can I use that?
Yes. So far, so good? Look at this equation. What do you notice?
We get minus y.
No x's, right? Only y's. So before we can minus y from both sides, which is what we want to do, we actually have to distribute this through though, right?
Yeah.
Because I can't subtract y from this side until like I've done that multiplication.
Wait, can you not like put like 100 times tangent 32? Like, can I not make it like a full with a number?
You can make it a decimal if you want to. I'm gonna hold on to all that till the very end,
Okay.
just because it makes the arithmetic a little bit neater if I don't have like crazy decimals running around in my problem. But yes, that's a nice observation, is that those tan 32s and those tan 37.5s, those are just numbers. They're like crummy decimals, like fill up your whole calculator, irrational numbers, but they're just numbers. So, Johnny, you're right. Now at this step, we want to get the y's on one side, right? So I can subtract 32y from, or 32, I'm sorry, y times tan 32 from both sides. Everybody good with what we did there? So what do I get when I do y tan 37.5 minus y tan 32? What do I get?
Tan 5.5.
You'd like that, wouldn't you?
This is the longest problem ever.
No,
Yeah.
we'll do longer ones.
Okay.
Just wait.
Would it be y tan 37.5 minus 3?
It would be,
Wait, why is the y still there?
How am I supposed to know?
This was always on the test. That's the answer.
almost.
How'd you get that? Where did the y go?
Okay, so if I did 5y minus 3y, what do we get? 2y. How'd you get the 2? You did that, right? I have 5y minus 2y, so I have 5 minus 2y. Remember, like the tans they're just a number. Like they're a lousy, crummy decimal, but they're just a number.
Wait, can we just divide it from y? But like, so pretend you didn't minus it. Can't I just divide y and then get rid of the y?
Well, then the y, then you have this thing over y. Right?
Oh,
Because you
yeah.
have to do it to everything.
Yep, I see.
So it just stays there?
So now, this is a number, right?
Yeah.
To get y by itself, we're going to do, what are we going to do to get y by itself now?
Divided?
Divide by this number. And then it's going to be calculator time. You're going to be mad though. Several seconds. I'll do that because it looked like people were still copying. Let me see. Okay. So I'm gonna write this using the horizontal fraction bar because this, the ability to get all the parentheses right on this is gonna be rather tough. I forget, it's 32, right? I have 100 tan 32 on top, and then tan 37.5 minus tan 32 on the bottom. Before I press enter, I want to make sure I'm in degree mode, which I wasn't. Woo! Good thing I checked. Press enter. So there's my y, about 438.64.
Wait, why couldn't I take away the tan 32 on both sides? Like, they cancel each other out?
Okay, so, yep. Here, let me ask you this question. If I have 3 over 5 minus 3, can I do that and just say, oh, this is 1 over 4? Shouldn't that be 3 over 2?
Yeah.
Yeah, can I reduce like what you're asking to do?
No.
No. Is that okay?
Yeah.
As a convincing argument as to why you can't do it?
Yeah.
As soon as you put real numbers in there and try to do it with like actual numbers, you're like, oh yeah, I wouldn't do that. Same idea here. Okay, this was like about 438.6. Guess what though? No, that's what we were asking for. We didn't want y. What were we trying to solve for in this problem? X, the height of the tower. Oh my God, Mr. Kulik, this never ends. No big deal though.
Are you gonna have one like this long on the test?
I don't know.
I'm gonna be failing that.
We're gonna need the whole class period.
So I'm gonna grab this guy and I'm just gonna plug my y in. Was it 37.5? So 336.6-ish. This is an equation for x.
I forgot we used to try to.
Right? That was one of the equations that we had. I just took that one. Anything with an x and a y in it will be fine.
Is it done now?
It is done now. Yes. 336.6-ish. So for next time, I would like you guys to work on this. Sure. You're welcome. Look like your hand. So I was getting.
Wait, what?
Pass across for me.
When did we do that? That was
Pass
so
across for
funny.
me, would you? Grace.
Oh, you're good.
What?
When did we do that?
Pass across.
Yeah.
No, on the wall.
Oh, guys. Grace. Grace is cutting bangs at the very second.
Other than being frustrated on the length of this final problem, how was today?
I'm not gonna lie, like, I don't remember anything you just wrote down, but
Oh, Addie.
it was okay. That was the one, how am I even supposed to, I don't even know where half those numbers came from.